Hi everyone! Today I'm going to walk you through a machine learning project, Iris classification in Jupyter Notebook. Let's begin. The first step is to import libraries we will use. Pandas, NumPy, and Seaborn that we are going to use for the data manipulation and the data visualization. And of course, Scikit packages that we are going to use for building our classifiers. And then I am using the read CSV function from Pandas to load our Iris dataset. We can take a look at the first couple of rows by using the head function. We can tell that we have 5 columns that including 4 flower features and the species column. Please remember, the species in the last column here is what we are interested in for the prediction. Okay, and then the next step is to understand our data. We can use info function here to have a quick look. So we can tell that for the 4 features and the species columns, we have 150 samples in total in our sample. And for all of them, there is none data in our dataset, which is great. It means there is no missing data. And for the 4 feature columns here, they share the same unit. They are all numerical types. And then we can take a further look at the species distribution. We can use the group by plus size functions here to see that. So we can tell there are 3 different species in total in our dataset: Setosa, versicolor, and virginica. And these species, they are balanced distributed in our dataset, which means each of them have 50 samples. Great! Let's move to the next step. So, in order to understand each feature that accounts for classification, we can visualize our data. So, it really helps to figure out the important features which account the most for the classification in our model. Here is an example. I use the pair plot function from Seaborn library to visualize our data. Here's the result. We can tell that the feature petal length and petal width, they are highly correlated with each other. And in addition, the petal measurement here too, they are better in differentiate species than the sepal ones. You can tell that. Of course, we can also make a correlation matrix to quantitatively examine the relationship between the features. So here's the result. The correlation matrix tells the same story that we saw above, which is the petal measurement. They are highly positive correlated to each other, while the sepal ones, especially for the sepal width, they are not. Cool. So, since we already understand our data, now we can split the data into training and testing set. The training set is what the model is trained on, and the test set is used to see how well our model performs in the prediction. We can use an inbuilt function which is called train test split to divide our data. Please remember, it will divide our data sample into 70% versus 30%. Here is how they look like. For example, for the X train and Y train, they are 70% of the training data of our data set. And for the test, they are 30% of our total data sample. Cool. Now, since we already have our data prepared, so we are good to go for the modeling part. We can use any classification algorithm to solve this problem, but I will use 2 simple machine learning models to show you how to do that. One is the decision tree, the other is the KNN algorithm, K nearest neighbor. The code here shows you how to build the model, train the model, and make predictions. By looking at their accuracy output, both of them obtain the accuracy above 90%, which is pretty decent. And the KNN model obtain a higher value, which is around 97.8% accuracy. By comparing these two models, KNN gives us the optimal accuracy. So, it's good for us to choose this algorithm for now. Then we could reduce the chance of overfitting and the variance in the data, which leads us to a better accuracy. Woohoo! That's great! That's it for today's walkthrough. Thanks for watching.